Good morning, everyone. In the previous class, we started motion in a straight line, and we discussed on the speed portion. And now today we will start the velocity. It is exactly similar, just the distance will be replaced by the term displacement. Otherwise, the definition will be exactly same. So velocity is the rate of change of displacement of an object in a particular direction is called its velocity. Velocity is equal to displacement by time taken. So you know that, and its dimensional formula is look at this dimensional formula. I want to mention this in the previous note. Maybe there might be some mistake in expressing the dimensional formula. There I think L was missing. So you already know how to find out the dimensional formula. So there are three main physical quantity which is normally expressed in dimension. One is mass for m for mass, capital L for length, and capital T for time. So we always try to express like this. And in this case, in the case of dimensional formula of speed or velocity, mass, there is no role of mass. Okay, just the distance or displacement by time taken. So distance or displacement, it is expressed by L. So the power L time divided by time taken. So basically L divided by T. L divided by T. So L is written as L to the power 1, and T when it comes in the numerator portion, it will be T to the power minus 1. And here is no role of mass, but normally we express combining these three physical quantities. So you have to write like m to the power 0, which is basically 1. So the dimensional formula will be exactly same for speed. So if you are asked to write down the dimensional formula of speed or speed or velocity, you will write like this: m to the power 0, L to the power 1, and T to the power minus 1. Now velocity is a vector quantity, you already know from class 9 standard. So because it has both the magnitude and direction, so it's a vector quantity. Now uniform velocity, exactly similar like uniform speed. If an object undergoes equal displacements, when you write the speed, uniform speed, just you have to write distance instead of displacement. And when you will deal with velocity, you have to write displacement in the place of distance. So if an object undergoes equal displacements in equal intervals of time, then it is said to be moving with uniform velocity. Non-uniform velocity or variable velocity is same. When velocity changes, the body doesn't move with constant velocity or constant constant velocity. So if an object undergoes unequal displacements in equal intervals of time, I already explained in the last class, exactly similar like this. Suppose a body moves, in the first 10 seconds it goes 10 meter distance. In the second next 10 seconds it moves 20 meter distance. So in that case, it is not covering the same displacements or distance in the equal interval of time. So basically the velocity is changing. So non-uniform or variable velocity will occur. Now the relative velocity, it is the important part. So I will little focus on it. So relative velocity, when two bodies, suppose what is relative velocity? Actually, when you are dealing with two bodies, if either of the two body, either one of the two body or both the bodies are moving, in that case relative velocity concept comes. Okay, so there means a velocity of any object when it is changing with respect to another object. Okay, listen carefully. When the velocity of an object, when it is changing with respect to the velocity of another object, so in that case relative velocity comes. Maybe one object is at rest, another object is moving, or both the objects are moving with the same speed, or both the objects are moving with different speed or velocity. Anyway, so basically so relative velocity, it is defined of object A with respect to object B. It is expressed as VAB is equal to VA minus VB. Suppose the object A is not moving. Okay, so object B is moving. Now in that case, VAB is the relative velocity of A with respect to object B. It will be, VA will be what? If BA is not, the object A is not moving, so BA will be 0, and VB is moving, so VAB, that is the relative velocity of the object which is at rest with respect to the object B, it will be just minus VB. But if you express, suppose the object A is moving and object B is not moving, so object B is at rest. So in that case, the relative velocity of A with respect to object B will be, VA will exist there, but VB will be 0, so VAB will be just VA. Okay, now whether the objects are moving in the same direction or in the opposite direction, or they are moving making an angle between them, according to these criteria, we write 3 different expressions. Suppose the both objects are moving in the same direction. In that case, it is expressed like this: VAB is equal to VA minus VB. They are moving with the same velocity and in the same direction. Sorry, they are moving with different velocities in the same direction. Suppose VA is not equal to VB. So in that case, VAB is written as like this: VA minus VB. And when two objects are moving in the opposite direction, in that case, VAB is written as VA plus VB. It is very normal, because VA is like this, and VA minus VB, in the place of VB you have to place minus VB. So basically VA minus VB, because the direction of the moving object B is in opposite direction. So it is in this direction from left to right, it is from right to left. So VB is equal to, that will be expressed, if we take VA velocity positive, so you have to take the VB velocity negative, because it is in the opposite direction. So in that case, VAB will be written as VA minus, within bracket, minus VB. So minus minus will be plus, so VA plus VB. Okay, understand? I am repeating once again. Suppose the body is moving in this direction, A body is moving left from left to right, and B body is moving from right to left. So if we take VA velocity as positive, then we have to take VB velocity as negative, because it is in the opposite direction of VA. Okay, so in that case, the relative velocity which is of A with respect to B, which is expressed as VA minus VB, in this equation, just you have to put VB in the place of VB, you have to put minus VB in this case. So the ultimate equation becomes VAB is equal to VA minus of minus VB, so becomes VA plus VB. Okay, so anyway, when two objects are moving at an angle now, okay, so suppose VA is in this direction, velocity of A is in this direction, and velocity of B is in this direction. Okay, and the resultant the relative velocity, that will be written as VAB, and that resultant velocity, suppose it is makes an angle theta with the velocity B, so then you have to write this expression. Basically that is a law of parallelogram law. You will know more about it in the next chapter, motion in a plane, when you will study the vector part. So just remember this equation: the relative velocity is expressed like this, and the direction, it is direction, this indicates the VAB, the direction of VAB, it will be expressed as tan beta. Beta is the angle of the relative resultant velocity with the VA velocity. So beta is the angle between VA and VAB. Okay, so in that case, the direction of VAB will be written as, you have to just remember this formula to solve out the problems. Okay, now average velocity, when the average concept comes, when the velocity changes. So if the velocity doesn't remain same, doesn't remain constant throughout the a particular interval of time, then you have to take the average velocity. So the ratio of the total displacement to the total time taken is called the average velocity. So average velocity will be total displacement divided by total time taken. So total displacement now the acceleration velocity is complete. Now acceleration, what is acceleration? Time rate of change of velocity is called acceleration. You know these terms. Okay, so acceleration is equal to change in velocity. Suppose the interval of velocity is delta v and interval of time is delta t. So if in delta t interval of time the velocity changes by an amount delta v, so you will get the acceleration delta v by delta t. So its unit is meter per second square, and dimensional formula is very easy because acceleration is equal to change in velocity. So change in velocity, the dimension of velocity is what? L t to the power minus 1 and divided by another time, so t. So L t to the power minus 1 divided by t, so it will ultimately give this expression L t to the power minus 2 and m to the power 0, that basically 1 becomes 1. So m has no role in case of this dimensional formula. So it is almost same like L t to the power minus 2 or m to the power 0 L t to the power minus 2. It is written like this because তোমাদের মাস, লেন্থ এবং টাইম তিনটেকেই ডাইমেনশনাল ফর্মুলার মধ্যে রাখতে হয়, সেই কারণে তোমাকে এমটাকেও রাখতে হবে। তো আদারওয়াইজ এটা এখানে এম এর কোনো রোল নেই, এম টু দি পাওয়ার 0 মিনস 1, ওকে। সো আলটিমেটলি মানে ফাইনালি এল টি টু দি পাওয়ার minus 2 is the dimension of acceleration, but you have to take the mass also. Now acceleration is also a vector quantity because it is the rate of change of velocity, okay. Now acceleration can be positive, 0 or negative. So positive acceleration means what? If the velocity changes, that means changes in velocity আমরা বলেছি with respect to time. Now এখন এই চেঞ্জটা কি হতে পারে? বাড়তে হতে পারে, there may be some increase in velocity during a particular interval of time, or there may be decrease in velocity in a particular interval of time, or there may be no change in velocity. So in that case, if there is an increase in velocity with respect to time, that will give a positive acceleration. If suppose velocity, if there is a decrease in velocity in a certain particular interval of time, so in that case you will get the negative acceleration. And if the velocity doesn't change during a particular interval of time, suppose during the 10 seconds the velocity remains same, so acceleration is 0, no change in velocity. So if a particle is accelerated for time t1 and for a time interval, suppose particle is accelerated for a time t1 with acceleration a1 and for a time t2 with acceleration t2. So t1 time e a1 acceleration niye body ta move koreche, আর next t2 time e it moved with an acceleration a2. So in that case average acceleration কি পাবে? Average acceleration তোমরা পাবে a1 into t1, that is the during the interval t1 interval of time, a1 into t1 will give the what? It will give the velocity, change in velocity. And during the interval of time t2, a2 into t2 will give the change in velocity during the interval of time t2. So basically total change in velocity divided by total time taken. So in the t1 time interval there is a change in velocity is a1 into t1, and t2 interval of time there is a change in velocity a2 into t2. So basically total change in velocity is a1 into t1 plus a2 into t2 divided by t1 plus t2. Now এই যে এক্সপ্রেশনটা তোমরা দেখছো, দ্যাট ইজ দ্য নর্মাল স্কেলার অপারেশন। যখন ভেক্টর অপারেশনে করবে তখন আলটিমেটলি আমরা নেব ইনিশিয়াল ভেলোসিটি আর ফাইনাল ভেলোসিটি নেব। সো সাপোজ ধরো সাপোজ ইন 3 সেকেন্ড বা ইন দ্য 3rd সেকেন্ড, suppose a body is moving and during the motion of the body, suppose at third second the velocity of the body, suppose 5 centimeter per second, and in the 5th second the velocity becomes suppose 6 centimeter per second. So during this 3rd and 5th second, that is during the interval of time 2 seconds, there is an increase in velocity 1 second. So ultimately net কতটা চেঞ্জ হচ্ছে velocity divided by total time. In that case তোমরা ভেক্টর অপারেশন যখন করবে তখন তোমার সাপোজ at t1 time the velocity is v1 and in the t2 time the velocity is v2. So ultimately the total change in velocity is v2 minus v1 and the time interval is t2 minus t1. So in that case the acceleration will be v2 minus v1 divided by t2 minus t1 will give the average acceleration, and that will be the vector treatment, okay. Now in that you can also use this formula. Now instantaneous acceleration, it is exactly similar to the instantaneous velocity যেমন তোমরা দেখেছিলে। সাপোজ in the delta t interval of time, delta t is a very small interval of time and delta v is a very small change in velocity actually. So during the interval of time delta t there is a change in velocity delta v, okay. Now suppose at any instant delta t tends to 0 means at a particular instant there is no change in time আর কি, এরকম যেটা বোঝায় আর কি। So in that case, delta v by delta t, that means when delta t is 0, or that is in 0 time interval, suppose the change in velocity is delta v. So in that case you can write acceleration a is equal to limit delta t tends to 0 delta v by delta t is equal to dv by dt. So that will give a velocity at a acceleration at a particular instant of time. Okay, so when you are asked the instantaneous velocity or instantaneous acceleration, that is the velocity or acceleration at a particular instant of time, then you can write dv by dt, or that is for acceleration, and in case of velocity you can write ds by dt. Now a car is moving, suppose at a point it is a to b point, in moving from a to b point, suppose at a point it is velocity 20 meter per second and b point 40 meter per second, and during the time interval then 10 seconds, so acceleration will be 40 minus 20 by 10, that will be plus 2 meter per second. I think there is a mistake, plus 2 meter per second square, it will be plus acceleration always be plus meter per second square. So I think there is a mistake here. Actually here it is written like change in velocity during the time interval. So 40 meter per second is the final velocity, 20 meter per second is the initial velocity, and divided by 10 seconds, so it should be 2 meter per second square, I think. Anyway, so and that is the acceleration between from b to c. You will correct this, meter per second square, meter per second square, meter per second square. Now in moving from b to point b to point c, the acceleration is minus 1 meter per second square. And if you are asked what is the acceleration in moving from point a to point c, then you have to take the final velocity as 10 meter per second and initial velocity as 20 meter per second. So 10 minus 20, and the total time interval is 10 plus 30, that is 40 seconds, divided by 40, and you will get the minus 0.25 meter per second square. Anyway, now the graphs are important, very important. So this is the displacement versus time graph. You also studied it in the class 9th standard. So for a stationary object means the body is not moving, it is at same place. So it is represented like this. Time is changing, but the displacement remains same. So displacement from it is taken from, suppose it is taken from the origin. So from origin, when it is taken from origin, it is always same, the displacement remains same. So there is no change in the position of the object. So for a stationary object you can express this graph. The body moving a constant velocity. Constant velocity means with the particular change in time. Suppose suppose the time is changing and the displacement is also changing, and it is changing at a constant rate. Okay, so in that case you are getting a straight line. So when you are getting a straight line, you can say that the displacement is changing with respect to time, but in a constant rate. Okay, so another case, when the acceleration we already know that displacement s is equal to ut plus half at square. You know this formula, you know this equation, s is equal to ut plus half at square. Suppose the body is the initial velocity of the body is 0. So basically in that case you will get the equation s is equal to half at square. Now half a is a constant, so basically s is dependent on t square. So displacement is dependent on t square, that is square of the time. Now at time 1, suppose at 1 second it has gone 1 centimeter displacement. In 2 it has gone 4 centimeter displacement. In 3 it has gone 9 centimeter displacement. So basically the graph is taking the parabolic way. Okay, so it is parabolic way. So now the body is moving with a constant retardation, is same, exactly same, but the nature of the curve is it will be a parabolic curve, but the কার্ভটা একটুখানি দেখো, এটা যেমন উঠছে, এটা কি হচ্ছে একটু উল্টো দিকে, মানে কমার দিকে, মানে শুরু হয়ে বেড়ে আবার কমার দিকে। Now the body is moving with the infinite velocity. Infinite velocity means at 0 time duration it is covering a large change in displacement. সেটা কি কখনো পসিবল? কখনো পসিবল না, মানে কোনো রকমের টাইম যায়নি, মানে একটা ইনফাইনাইট অ্যামাউন্ট অফ তার ডিসপ্লেসমেন্ট হয়েছে, এটা তো হয় না। সাপোজ তুমি এরকমও ভাবতে পারো Infinite velocity means suppose at 0 time interval you have gone to 2 centimeter. So in that case velocity will be 2 centimeter divided by 0 second. So ultimately it will undefined. Why? Because no time has elapsed, কোনো টাইম শিফট হয়নি, ঘড়ির কাঁটা এক জায়গায় রয়েছে, হ্যাঁ, মানে জিরো চেঞ্জ ইন টাইমেতে তুমি একটা ডিস্টেন্স কভার করে গেছো, সেটা কখনো হয় না। সো ডিস্টেন্স কভার করতে গেলে একটা টাইমেরও সেখানে তোমার লাগবে। সো ইন দ্যাট কেস ইট ইজ অ্যান ইম্পসিবল কন্ডিশন অ্যান্ড ইট উইল বি এক্স্যাক্টলি লাইক দিস। সো অ্যাট জিরো টাইম ইন্টারভাল মিন at a particular instant you have gone like this. So it is impossible case. Now another important, slope of the displacement and time graph will give the average velocity. Okay, now velocity and time graph is same, moving with constant velocity. When any object is moving with constant velocity, that means when time is changing but the velocity remains same. So it will be a parallel line, it will be a line parallel to the x-axis or time axis anyway. So moving with a constant acceleration is velocity is changing with time but at a particular rate or constant rate. So when velocity changes with time at a constant rate, the graph will be like this. And the body moving with constant retardation, when the initial velocity is not zero. So initial velocity, there is an initial velocity, we can see that. Now initial velocity থেকে কি হচ্ছে, velocity change হচ্ছে কিন্তু সেটা কমছে, so it is decreasing with respect to time at a constant rate. Now this graph is also same. Now moving with increasing acceleration, the acceleration moving with increasing acceleration is same with like increasing velocity. So acceleration টা চেঞ্জ করে যাচ্ছে at a particular time instant এ যে acceleration ছিল পরের time instant এ আরো বেশি acceleration, তারপরে instant এ আরো বেশি acceleration. So in that case the acceleration, that means the velocity is not changing with time at a particular rate, constant rate. Okay, it is changing with a variable rate. So in that case you will get the graph like this. Moving with decreasing acceleration will be same. So in both two cases you will not get a straight line, which you are getting in the case of constant rate এর ক্ষেত্রে যখন তোমরা পেয়েছিলে যে acceleration is taking at a constant rate, velocity was changing with time at a constant rate, and velocity is increasing or decreasing at a constant rate, you are getting the straight line. But in these two cases you will not get the straight line, and slope of the velocity and time graph will give the average acceleration. Now acceleration and time graph যেটা আছে আমাদের সেটা দেখতে পাচ্ছি, যদি acceleration remains same with respect to time, that means uniform acceleration আর কি, acceleration is not changing. A constant acceleration যদি একটা car move করে, তো in that case you will get a straight line parallel to the time axis. And when object is moving with constant increasing acceleration, that means the car is the acceleration is increasing but at constant rate. So in that case you will get the graph like this, and the acceleration is changing but decreasing but at a constant rate, you will get the graph like this. Now for equations, you already know this, v is equal to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time, and it is the displacement. You know the formula also, and this is the formula, and this is the new formula, distance travel in nth second. Okay, so there is no need right now there is no need to derivation. If in future time, if it is possible, I will show how to derive this formula, but just for solving problems you have to remember these formulas. Okay, now motion under gravity, when you are dealing with gravitational motion, just in case of the acceleration a, you have to place the gravitational acceleration g, otherwise it's same. Another one change which is required in this case, which is in case of displacement s or displacement s, you have to write the height, because you are the body is moving either in the upward direction from the earth surface, or it is coming towards the earth surface. So basically we are dealing with height, so h means height. So in the place of displacement s, you have to write h. So otherwise the formula remains same. So v is equal to u plus gt, h is equal to u plus gt square, v square is equal to u square plus 2gh when the body is falling towards the earth. Okay, but under the gravitational acceleration. But if you throw any object in the upward direction against the gravitational acceleration, you have to put minus sign in the place of plus sign. So in that case you will get the formulas v is equal to u minus gt, h is equal to ut minus g, sorry, in this case there will be a half, I think a mistake is there, ut minus half gt square. I will send the note in the correct form. Okay, so anyway, and the v square is equal to u square plus 2gh. And from these formulas you will get the time of, suppose, a body to reach a particular height, how much time is required to reach a particular height or maximum height, and that is the formula Ta is equal to u by g. Okay, and h max is the maximum height. It is obtained by putting the final velocity 0. We know that the formula v is equal to u minus gt. So in the place of v, if we put 0, because when it, after covering a certain distance or maximum height, the velocity remains 0, and again the body again starts to come back towards the earth. So you have to put the final velocity v0 in order to obtain the maximum height. So you will get this formula automatically. So these are the formulas you have to remember to solve the problems. And thank you. This is for today's class.